Alright, welcome. This is the introduction video on the major concepts. I'll do another one about the applications. You could look at that as well. Alright, let me get rid of the video for a moment. Okay, if you notice in my little diagram I have here, I have two lines on the coordinate plane. And each line represents a linear function, right? Both of them are functions. So here I have my red line, and then here I have my blue line. Now what's particular about this is they cross at this point of intersection here, which I can call 2, 2. What does that mean? That means that the x value of 2 and the y value of 2 is shared by both of the lines, so it would work in both of the lines, or it is a solution of that system. Okay, it's the location that both those values of the domain and range are true for both of them. So what is the system of equations? It's two or more equations and two or more unknowns, and in this case I'm looking at it visually. Now what I want to do is I want to solve this system by graphing. Well, that's easy. Y equals 1/2 x minus 4. I could graph that. Y equals negative 2/3 x plus 3. I could graph that. Well, let's see. How would we graph those? Well, if I could move this up just a little bit and put my coordinate plane back on here. So the first one was y equals 1/2 x minus 4. Let me just kind of move this maybe up here. No, that's not going to work. Right here. Okay. So 1/2 x minus 4. That was the first one. Well, the y-intercept is negative 4. And remember, it was 1/2 x. 1/2 x. So that would go right here. 1/2 x minus 4. Now the second one was negative 2/3 x plus 3. I'm going to go plus 3, negative 2/3, which means I'm going down 2 to the right 3. All right, let's make sure we understand this now. Okay. The first one had a y-intercept of negative 4 and a slope of 1/2. Y-intercept of negative 4, slope 1/2, up 1 over 2. Second one, y-intercept of plus 3 and slope of negative 2/3. 3, negative 2/3. Now the question is, where do the two lines cross at? The two lines cross at 6, negative 1. What does that mean? That means that the value 6, negative 1 should satisfy both of those equations. 6, negative 1. If I plug in a 6 right here, I will get a 3. 3 minus 4 is negative 1. If I plug in a 6 for this x, 6 and 3 divide out, that's 2 times a negative 2, which is negative 4, plus 3 is negative 1. So this point right here satisfies both of those equations at the same time. It is therefore a solution to both of those equations. All right, so that's how you graph. Now the question is, could I do that same problem on the calculator? And of course the answer is yes, we could. So here we go. Try to get my light where you could see it maybe a little bit better. There you go. So I plug in my functions in the calculator on my equation editor, 0.5x minus 4. Notice I did the negative 2/3 x, negative 2x divided by 3 plus 3. So I'm going to hit zoom, zoom standard, or zoom 6. And here's my first curve and my second line, that is. First line and second line. Notice they're crossing right here. Now I could hit the trace key and notice y1 over there in the upper left hand side, and I could hit 6, and lo and behold, that is a location where both of them cross. I could move my down arrow and hit 6, and also notice the location where both of them cross. So I could find the intersection that way, or I could actually use the intersect key, which I talked about before, and that's located right here on item number 5. So I hope that helps you see how to solve that system on the calculator. Now what we're going to do is we're going to talk about substitution. Now, to use the substitution method, one of the equations has to be solved for one of the unknowns. So notice we already have this bottom equation solved for the y. So just substitute this in for the y at the top. Remember that they had to satisfy both of them at the same time. So I'm going to take the 2x plus the y right here is negative 2x minus 3, and I'm going to minus 3. What's going to happen to 2x minus 2x? That's going to go away. I'm going to have negative 3 is equal to negative 3. Now the question is, what type of solution is this? And this type of solution is, this is always true, so that's all real numbers, or a dependent solution. Alright, sorry, I messed up right there. I need to talk about consistent and inconsistent. Inconsistent is somebody that doesn't, let's just say they don't tell the truth. There's no solution anytime, okay? So you can't guarantee any solution from these folks. This would be two lines on the coordinate plane. They don't touch. They're parallel with different y-intercepts. They would never cross. That is called inconsistent or no solution. Now, we're going to talk about these two. They're called consistent. In other words, they tell the truth. We know they tell the truth, either one-time truth or all the truth. So here we go right here. These two lines cross right here. They cross one time. That is called an independent solution. And the second one, dependent, would be when the lines are right on top of each other. Okay? So I got a red line and I got a blue line. And what color does red and blue make? Makes purple. So that would be purple what? That would be purple all of the time. So these are infinite number solutions. Remember, inconsistent, no solution. Independent, one solution. Dependent, infinite solutions. Hope that helps. All right, I want to solve this problem using the substitution method. What I need to do is solve one of the equations for one of the unknowns. Notice this top equation has a y by itself. So I want to, let's just do it, okay? 2x plus y is equal to negative 3. Move the 2x. So I'm going to say y is equal to negative 2x minus 3. All right, now I'm going to do substitution. Y is, let's call this blah, okay? I'm going to plug that in for the y in the second equation. So let's do this. 3x minus 2 times blah, right? Okay. Is equal to negative 8. So 3x plus 4x plus 6 is equal to negative 8. That 7x plus 6 is equal to negative 8. Subtract the 6, negative 14, so x is negative 2. I know the value of x. Can I find y? Yeah. The easiest place to go and find y is to take that and plug it in to my expression blah. Negative 2x minus 3, that's what y is. So y is equal to negative 2 times negative 2 minus 3, which is negative 4, plus 4 minus 3, which is y is 1. So my answer to this problem is x is equal to negative 2 and y is equal to 1. I could write it as an ordered pair if I wanted to, negative 2 comma 1. Now how do I know it's true? Because I could plug it into both equations and it should satisfy both equations. That is the gist of the substitution method. Okay, this is the elimination method, which basically it says get rid of one of your variables. Now notice I just can't subtract them. They don't match. The coefficients don't match. I want to eliminate it. Well, I could get rid of the x by multiplying by 3 and 5 perhaps. But notice over here the signs are already different. What would happen if I multiplied the top by 2? Let's just rewrite that equation. That would be what? 10x minus 6y is equal to negative 2. Now, we want to eliminate the y, so don't I need a plus 6y at the bottom? Yes, I do. So I should multiply the bottom equation by 3. All right, let's go through that. That's going to be 9x. Yes, that is plus 6y, and then that's 21. Now we could add both sides together. Let's add the left sides together. I get 19x. Let's add the right side together. I get 19. So x is 1. Okay. Can I find y? Now I can find y. There's really not an advantage to either equation, so I'll just use the top one. 5 times x minus 3y is equal to negative 1. Try to go back to your original problem here. Remember, negative 1 is going in for that x. So 5 minus 3y is equal to negative 1. So negative 3y is equal to negative 6. Y is 2. So x is 1 and y is 2. Okay, you need to be able to check those, and I'll show you an easy way to check those. What we could do, we're just going to use this other equation, 3 and 2. Remember, that's the x, and then that's the y, right? Okay. Well, my answer was x is 1 and y is 2. So let's multiply. 3 times 1 is 3. 2 times 2 is 4. What's 3 plus 4? 7. Okay, according to that second equation, it should be 7, and they match. You could extend that to the other equation too and check both at the same time. That is another way to check it. So you could solve a system by elimination. Go through that a couple times if you need to. Now we're going to do a problem related to two nonlinear or a nonlinear system. If we notice on the top equation, I have an x squared. If I move that x squared to the right side, I'm going to have y is equal to x squared minus 1. Now we recognize that as a parabola, it's opened up this way, but it's moved down 1. All right, if we took the second equation and solve for y, we have y is equal to x plus 1. Notice that's a line, okay? Its y-intercept is 1, and its coefficient here is 1. Its slope is 1. So could we graph these? Sure. All right, so we notice we have one solution right here where both of them cross. That would be negative 1 comma 0. But what about this other location here? It's really not clear. Plus the way I, drew my graph, it may not be exact. Let's see what happens to both of them at 2. If I plug in a 2 right here, I have 2 squared, which is 4 minus 1 is 3. So that would be 2 comma 3. If I plugged in a 2 right here, that would be 2 plus 1 is 3. So yeah, 2 comma 3 is an ordered pair that's shared by both of them. So the answer there would be 2 comma 3. There would be 2 answers. Now, what are some other ways of solving that? I could get the calculator out and use intersection, okay? Or I could solve algebraically. Okay, now this may seem a little advanced, but it's not too bad. I solved algebraically. I set both of the right sides equal to each other since they both were equal to y, and I have this expression right here. I moved everybody to the left and have this. I factored that. Notice it's in a quadratic equation, and x is 2 and x is negative 1. Now remember, you still have to find the y's, okay? But those are the values for x. That's another way to solve that. So be sure to watch the second video on applications to help you with systems of equations. Good luck.